Welcome to Vector's Open Patreon tutorial. This video will take you through the concept of lists in Sverchok. Sverchok is a geometry manipulation tool developed in Python. So many Python concepts can be introduced into Sverchok. A list is a type of data storage in Python. A list is represented by a parenthesis. Usually also uses the tuple type to store data. A tuple is represented by a parenthesis. They are somewhat different, but can be ignored in Sverchok. Sverchok will convert them as needed. So, I'll call them collectively here as a list. Next, let's understand how lists are expressed in data. A vertex data is represented using a list. The list holds the values of the coordinate axes. The vertex data of an object is also represented using a list. The list holds all its vertex data. This adds a list hierarchy. Such nested lists can be found everywhere in Sverchok. Again, we go on to add a list hierarchy. It is possible to obtain a list of vertex data for many objects. The list contains the vertex data of each object in turn. This is how the data is stored within Sverchok using the list. The data is stored at different levels by nesting the lists one after the other. So, the concept of list hierarchy is very important. This will determine exactly what you are in control of. Now, let's go back to Sverchok and verify these. We choose a generator. You can observe that its data is a constantly nested list. This is exactly the same as the description. This is how Sverchok stores geometric data. Based on lists, we can implement many functions. For example, implementing the repetition of geometric data, or to extract a point in the geometry. There are many nodes in the list menu that manipulate the list. You can learn about them by looking at their documentation. To facilitate setting the data hierarchy, Sverchok provides a shortcut for setting the global output data hierarchy. You need to enable this function in the side panel. The output sockets of the nodes now have a menu. You can regroup the data by adjusting the data level. For example, You can split elements into object hierarchies, and the node will show the number of elements in the object hierarchy. Adjusts the data hierarchy to its initial state. Later on, I will give a simple example. Introducing the application of different levels of data. You will find it so clever. Here I use some floating point numbers to control the scaling. Each floating point value controls the scaling of a single point. The object hierarchy at this point has only one data. Then the data within this one data naturally corresponds to each point. You can think of this as element level control. Next, we change the data level to the object level. Note in order to match multiple objects of the input. The corresponding geometric object is generated. At this point, each value within the data controls the overall scaling of the corresponding object. Now we are performing control at the object level. There is also a List Levels node in the List menu. It provides a more free control of the levels. This makes up for some shortcomings of the shortcut. I'm sure you have a first idea of the list with these descriptions. If you like my content, support me on the various platforms.